Good morning. I'm Miss Rezi Rodriga, your teacher for today. So we're going to discuss exponential function. Suppose that a bacterial culture is growing at a rate such that after each hour, the number of bacteria doubles. If there were 1,000 bacteria when the culture started to grow, then after 1 hour, the number of bacteria will be 2,000. After 2 hours, there will be 4,000 and so on. So our equation will be y is equal to 1,000 times 2 raised to x. So if the number of hours is 0, 1, 2, 3, and 4, let's substitute the variable x in the equation. Then the number of bacteria in the table is 1,000, 2,000, 4,000, 8,000, and 16,000 because it doubles. So when we use exponents, 1,000 times 2 raised to the number of r. So 1,000 is equal to 1,000 times 2 raised to 0. Then for 2,000, 1,000 times 2 raised to 1. For 4,000, 1,000 times 2 raised to 2. For 8,000, 1,000 times 2 raised to 3. And the last, 16,000 is equal to 1,000 times 2 raised to 4. So what is an exponential function? So exponential function is a function in which the variable is in the exponent. If x and b are real numbers such that b is greater than 0 and b is not equal to 1, then f of x is equal to b raised to x is an exponential function with base b. The next slide is about the law of exponent. So if a and b are positive numbers and x and y are any real numbers, then there are 5 law of exponents here. The first one is a raised to x times a raised to y is equal to a raised to x plus y. So if you are multiplying with different exponent, you just add the exponent and copy the base a. For law of exponent 2, a raised to x all over a raised to y is equal to a raised to x minus y. Here, if you divide same bases with different exponent, you just subtract the exponent x minus y. For the third law, a raised to x multiplied to another exponent is equal to a raised to x times y. Quantity a times b raised to x is equal to a raised to x times b raised to x. So you just distribute the exponent to the first base a and then to the second base b. And for the last, quantity a divided by b raised to x is equal to a raised to x over b raised to x. So now let's solve exponential equation. So we will use the different law of exponent in solving the exponential equation. So we also use this property that if x and y are real numbers and if b raised to x is equal to b raised to y, then the result will be x is equal to y. So let's see. the steps in solving exponential function. So the first step is to rewrite each side of the equation as an exponent expression having the same base. The second one is to use the law of exponent. And the last step is to check the solution by substituting it to the equation. So let's have example 1. 64 is equal to 8 raised to x minus 2. So what are you going to do first is to rewrite with same basis. 8 raised to 2 is also 64 is equal to 8 raised to x minus 2. In this case, we have same basis, so we will just get the exponent. So 2 is equal to x minus 2. And then solve for the value of x, which is 4. And for the last step, let's do the checking. Substitute positive 4 to the variable x. Therefore, 64 is equal to 8 raised to x minus 2 will be substituted by 64 is equal to 8 raised to 4 minus 2. And then, when you subtract 4 minus 2 is equal to 2, therefore 64 is equal to 8 raised to 2. For the second example, 3 raised to 2x is equal to 81. So first step is to write with same basis, 3 and 3. 3 raised to 2x is equal to 3 raised to 4. Because 3 raised to 4 is equal to 81. And then, when you get the exponents, 2x is equal to 4, you're going to divide both sides by 2. Therefore, x is equal to 2. For the checking, just substitute 2 to the variable x. In the equation, 3 raised to 2x is equal to 81. Next, 3 raised to 2 times positive 2 is equal to 81. Multiply 2 to positive 2 is 4. 3 raised to 4 is equal to 81. 1/2 raised to x plus 2 is equal to 16 raised to negative x. So, to apply the law of exponent, the reciprocal of 1/2 is 2 over 1 raised to negative 1 because 1/2 has an imaginary exponent, positive 1. Then copy the exponent, x plus 2 is equal to 2 raised to 4, the equivalent of 16, raised to another exponent, negative x. Next step is to distribute negative 1 to the exponent, x plus 2. So 2 raised to negative x plus 2 is equal to 2 raised to 4 raised to negative x. Next, 2 raised to negative x minus 2 is equal to 2 raised to negative 4x. So you just multiply the exponent. And for the checking, we have the exponents here is negative x plus 2 is equal to negative 4x. So distribute negative times positive x becomes negative x. Negative times 2 is negative 2 is equal to negative 4x. Negative x plus positive 4x, because when you transpose negative 4x becomes positive 4x. And then negative 2 will be transposed to the other side, will become positive 2. Then combine like terms, negative x plus 4x becomes 3x is equal to positive 2. Then divide both sides by positive 3. So 3x divided by 3 is x, and 2 divided by 3 is 2/3. Therefore, our answer is x is equal to 2/3. The next thing is to graph the exponential functions. So there are two steps here. First is to make the table of values, and the second step is to plot the points and connect using a smooth curve. So let's try to sketch the graph of f of x is equal to 2 raised to x. So if the value of our x here is negative 3, negative 2, negative 1, 0, 1, 2, and 3, our y will become this one, 1/8. When you divide that, we will have the denominator 0.125. For negative 2, our f of x is 1/4, and the decimal of that is 0.250. For negative 1, 1/2 is equal to 0.500. For 0, 2 raised to 0 is 1. Any number raised to 0 is 1. And then 2 raised to 1 is 2. 2 raised to 2 is 4. 2 raised to 3 is positive 8. So when you're going to sketch, you need to get the coordinates of each points, and the graph will be looking like this. F of x is equal to 2 raised to x. So note that the graph passes through 0 and 1, and the graph is asymptotic to the axis. For example number 2 is to sketch the graph of f of x is equal to 1/2 raised to x. So our value of x here is negative 3, negative 2, negative 1, 0, 1, 2, and 3. When you substitute that, our y will become this one. So 1/2 raised to negative 3, we will have positive 8. 1/2 raised to negative 2 will have positive 4. Then 1/2 substitute negative 1 becomes positive 2. 1/2 raised to 0, any number raised to 0 is 1. 1/2 raised to 1 is still 1/2. The equivalent of that is 0.500. In the decimal, we can use 3 decimal places for the decimal. 1/2 raised to 2 is equal to 1/4. The equivalent of that is 0.250. And for the last, 1 half raised to 3 is positive 1/8. The equivalent to positive 1/8 is 0.125. So if you're going to graph that, you get each coordinates and plot it to the graph or the Cartesian plane. And it will be looking like this. F of x is equal to 1 half raised to x. So what's the note? The graph here passes through 0 and 1. The graph is asymptotic. So if we're going to go to number 1, notice that the function is 1 to 1 and the function here is increasing because b is greater than 1. When you're going to look, f of x is equal to 2 raised to x, the base is greater than 1. That's why the graph is also increasing, going upward. Well, in the second example, the function here is 1 to 1 also. The function is decreasing, as you can see in the y, because b is in between 0 and 1. If we're going to look at the given, f of x is equal to 1 half raised to x. 1 half is our base, 1 half is in between 0 and 1. So if we're going to summarize that, the properties of exponential function graph are the following. The function is 1 to 1. B, the graph passes to 0 and 1. C, the graph is asymptotic to the axis. D, the function is increasing when b or the base is greater than 1. And E, the function is decreasing when b or the base is in between 0 and 1. For the natural exponential function, which is defined by f of x is equal to e raised to x, where x is any real number, the number e is irrational and is approximately equal to 2.718. So if you're going to try that on your calculator, press shift or just the E button and the value will have 2.718. So let's try to find the value of the following. So correct up to 3 decimal places by using your scientific calculator. For e raised to 4, you should have an answer of 54.598. For e raised to negative 4, you will have 0.050. For e raised to 0.5, you will have 1.649. For e raised to negative 3/4, you will have 0.472. So for your activity for today, I ask you to bring the materials. So using a graphing paper, prepare a table of values for the following function. So give the domain and range of each function. For the domain and range of exponential, it's just like a linear function where x and y is infinite. It can be a positive integer or negative integer, including 0. So for number 1, y is equal to e raised to x. Number 2, y is equal to 1/5 raised to x. Number 3, y is equal to e raised to 2x minus 1. And 4, y is equal to 1/4 raised to x plus 2. So first thing to do is to prepare the table of values. So you can assign 0, 1, 2, 3, then -1, -2, -3, and then plot the points after solving for the y. Okay, you can submit this to our face-to-face class, no? So if you have question, just message me in the MS Teams. So thank you for watching and good luck.